Okay, in this assignment, it's just more work with rational exponents. You're not going to have a radical at the beginning, okay? So, but you're still thinking the same thing. You have a parentheses, and in the parentheses, you have x to the power of 2/3, and then negative third power outside, okay? X to the 2/3 power, negative 3 outside. So you're going to set up your little plan of attack here. So the only base you have is x, okay? And then you take 2/3 times negative 3. So 2/3 times negative 3 gives us negative 2. Now you have a negative exponent, so now you need to utilize this step to move your x to the bottom, and the 2 becomes positive, and you put a 1 over the top. Now, at this stage in the game, do you have any fraction exponents? You don't. So since you don't have any fraction exponents, these next 3 lines you can just say to heck with. And then you can't really simplify x to the second, so 1 over x to the second is the answer. Okay, next problem. We have 5, and then in a parentheses we have x to the 2/3 power, and then outside you have a negative first power. So set up your plan of attack here. So the bases we have are 5 times x. So 5 is to the first, but that doesn't get distributed. Then 2/3 times negative 1 is negative 2/3. Now the 5 to the first stays where it's at because it has a positive exponent, but we need to move the x to the other side of the line so it can be to the positive 2/3 power. Okay. Alright, now we do have a fraction exponent, so we do need to utilize these steps. So what I do first is I just move the whole exponent over here, and the fractional exponent move over here and circle the bottom. Okay. Now, is there any way you're going to find x on your list of cubed roots? No, you won't. Okay. Now, at this stage, you want to circle the base on the bottom. It has a fractional exponent, so it needs to be rationalized. That's what this step is for. If you have fraction exponents on the bottom, they need to be rationalized. So I just write down what I have, okay, on top. Then on bottom I write x to the 2/3 power, and then I get rid of that fraction by timesing by x over 3, and 3 minus 2 would leave me with 1. Okay. Now you also have to multiply the top by x to the 1/3 power. Now 2/3 plus 1/3 is 1 whole, so we now have 1 and x to the 1 power. Okay. Now over here is when we translate our rational exponents into radicals. Okay, 5 to the first and x to the first are not rational exponents, so they just go here. And then my rational exponent has a 3 on the bottom, so I make a cubed root. And then inside of it I put x to the first, or just x. Then 5 to the first is 5. X to the first is x, and then I just put a cubed root. There's no way you can simplify x. Okay, in my next problem we have x to the 2/3 power, y to the negative 1/6 power, and then a negative 12th power outside of that. So my bases in the problem are x times y, and then I distribute the exponents. So 2/3 times negative 12 is going to be negative 8. Then negative 1/6 times negative 12 is going to be positive 2. So we need to move the x to the 8th down to the bottom so it can be a positive exponent, then y to the second on top. Now, at this stage, I don't have any rational exponents. They're whole exponents, so all these 3 steps can be discarded, okay? Then y to the second over x to the 8th. Remember, I only need to worry about these if they're rational exponents. This is to check and see if the rational exponent can be simplified on the spot with my sheet, okay? This right here is for rationalizing rational exponents on the bottom, and this is for converting the rational exponents into a radical. And this is for just simplifying. So that's the answer. Okay, next problem. We've got a parentheses with a fraction line, a division line. On top you got x to the negative 2/3 power. On bottom you have x to the negative 1/3 power, and then you have a 15th power outside. Okay, so I have an x on top and an x on bottom we need to distribute. So negative 2/3 times 15 is going to be negative 10. And then negative 1/3 times 15 is going to be negative 5. So remember how to handle when I have a base, the same base on top and bottom. We cross out the x that's to the smaller power, and then subtract that from the bottom. So it's negative 5 minus negative 10, which is negative 5 plus 10, and that would give you 5. So that's a positive exponent, so it stays in the position it's in, but I need to cover the top up with a 1. And do I have any more rational exponents? No, I don't. Okay, the only exponent I have is a whole exponent, so then these three steps can be discarded. We have 1 over x to the 5th is the answer to the problem. Okay, my next example, I have y to the 1/2 power times y to the 3/10 power. Y to the 1/2 power times y to the 3/10 power. So you have a base of y, but with multiplication you need to add the exponents, 1/2 plus 3/10. I think it's 4/5, not sure, but yep, 4/5. Okay, it's not a negative. I don't have any negatives, so I cross that out. Now, I do have a rational exponent, so I need to utilize these steps. So I pull over there are no bases with whole exponents, just the base with the rational exponent. So you circle the bottom. If you look at I don't even have a fifth root list, and if I did, y, a variable's not going to be on there, so don't have it. Now, the rational exponent that we have, is it on the bottom? No, it's not, so I don't need to use this step. There's no rationalizing I need to do. You don't need to rationalize the top. That's just the bottom. Okay? Now, this step is for converting my rational exponent into a radical. So I have a 5 on bottom, so it'll be a 5th root, and then y to the 4th. And then I don't think you can simplify a y to the 4th power, so that just remains the same. Okay, next problem, division line. We have x to the power of 3/5 divided by x to the power of 1/10. So I've got an x on top and bottom. There's no parentheses, so it would just be 3/5 and 1/10. Okay, if you don't know which one's smaller, if you get 3 out of 5 on a test and 1 out of 10 on a test, which one's worse? Well, the 1/10, so I minus 1/10. You should have at least enough sense to know that. So 3/5 minus 1/10 is going to be 1/2. Okay, it's a positive 1/2, so I don't need to be moving. It stays in its position. Okay. Now, we do have a rational exponent, so I pull that over here. I circle the bottom. Now, on a square root list, that's degree 2, x isn't going to show up. Now, do we need to rationalize? No, because the rational exponent that I have is not on the bottom. Now, make that into a radical. So it would be a radical with a 2, and then inside it'd be x to the power of 1, which is just x. So that's about as simplified as you can make that, the square root of x. Okay, next problem. On top I've got x to the 2/3 power and y to the negative 1/4 power. On bottom I have x to the 1/2 power, y to the negative 1/2 power. Okay, so on top I've got x times y, and then on the bottom I have the same thing. Remember, with a fraction you want to do the tops and bottoms separately. So x on top's to the 2/3 power, the y on top's to the negative 1/4 power. 1/2, negative 1/2. Okay, 2/3 and 1/2. Well, 1/2 smaller than 2/3. If you get 1 out of 2, that's 50%. 2 out of 3 is above 50%. So you subtract 1/2. 2/3 minus 1/2. Going to be 1/6. Okay. So x to the 1/6 power. So x to the power of 1/6 is what that says. That's hard to read. I'll just put it over here. X to the 1/6 power. Now, as far as the y's go, you have a negative 1/4 and a negative 1/2. Now, if they were positives, the 1/4 smaller, but then when you're dealing with negatives, the bigger the negative, the smaller it is. So minus negative 1/2, which is plus plus. So you take negative 1/4 plus 1/2, and it's y to the 3/4 power. Okay, and that's on top. Now both these exponents I ended up with 1/6 and 3/4. They're positives, so there's no reason to move them. Okay. Now we do have rational exponents, so we move them both over here. I don't even have a list for 6 roots, and if I did, the variable x isn't going to be on it. And on the 4th root, y doesn't show up on that, so they can't be simplified. Now, do I need to do this line? Now, these rational exponents are on top. They're not on bottom, so I don't need to do that. No rationalizing necessary. Okay? Now, make these into roots. Now, you have a 6 and a 4, so you need to make 2 separate roots, one with a 6, one with a 4. And you're going to have x to the 1st, which is just x, and y to the 3rd stays there, and you can't simplify those. So it's just the 6th root of x times the 4th root of y to the 3rd, and that's simplified. So if you have 2 different bottom numbers, you just make 2 separate radicals. Okay, next problem. I have one big parentheses, and inside on top I have 16x to the 14th power. On bottom I have 81 y to the 18th power. Then I have a 1/2 power outside. So on top you got a base of 16 and a base of x. On bottom you got an 81 and a base of y. So 16 to the 1/2 power is 1/2. 1 times 1/2. Then 14 times 1/2 is 7. Now an 81. 1 times 1/2 is 1/2. Then 18 times 1/2 is 9. So we have 16 to the 1/2 power, to x to the 7th power, 81 to the 1/2 power, y to the 9th power. None of them are negative, so they all stay in their positions. Okay. Now, put your whole exponents down. You do have some rational exponents, but you write the wholes down first, followed by the rationals. Now circle the bottom. Now check your list. See if those are on there. They're square roots because they're seconds. 16 is there. It's equal to 4. So now the 16 and the 2 go away, and I have 4 to the 1st power. Okay. And then is 81 on the list of square roots? It is. It's 9. Okay. So that goes away, and it becomes 9 to the 1st power. So now, I don't have any rational exponents on bottom. The exponents I do have are whole, a 9 and a 1. Okay, y to the 9th, 9 to the 1. So this is not necessary. And I don't need any radicals either. The reason I don't is because that's a whole, that's a whole, that's a whole, that's a whole. Okay, and then you just simplify. So 4 to the 1st is 4, 9 to the 1st is 9, and then x to the 7th, y to the 9th. So I was able to get rid of my rational exponents there. That's why you want to look at that. Okay, my next problem, I have a parentheses. On top I've got 8x to the 6th, and on bottom 27y to the 9th, and then outside I have a 1/3 power. So on top I've got a base 8 times a base x. On bottom you got a base 27 and a base of y. So 8's to the 1, but 1 times 1/3 would be 1/3. 6 times 1/3 would be 2. 27's to the 1, 1 times 1/3 is 1/3, and 9 times 1/3 is 3. Okay, none of them are negative. None of the exponents I ended up with are negative, but we did end up with some rationals. So write your whole ones down, x to the 2nd, y to the 3rd. Then put your bases with the rational exponents, 8 to the 1/3, 27 to the 1/3. Okay, so circle the 3's and look at your cubed root. See if 8's there. It is. So 8 and the 3 are replaced with 2, because that's what that means, is a cubed root of 8. Okay, 2 to the 1st now. 27 to the 1/3. Well, 27's a perfect cubed root. It's equal to 3. So now that goes away, and I have 3 to the 1st. Now, on the bottom, I have nothing but whole exponents with a 3 and a 1, so we don't need to worry about rationalizing. Okay. Now, do I have any rational exponents at all? 3, 1, 2, 1. No, we don't, so we don't need to be making any radicals. So 2 to the 1st is 2, 3 to the 1st is 3, x to the 2nd, y to the 3rd. Remember, this is for simplifying rational exponents on bottom. This is for simplifying any rational exponents on top. Okay. Okay, next problem. 125 to the negative 1/3 power. So we have a base. The only base I have is 125, and it's going to be to the negative 1/3 power. Now you need to reciprocate it, because it needs to make its power positive with a 1 on top. Okay, now we need to utilize this because we do have a rational exponent. So I circle the bottom of the rational exponent and check the cubed root list. Okay, 125's here, it's 5. So we now have 5 to the 1st. Now on the bottom, your exponent's a whole, 5 to the 1st, so don't need it. And you don't have any rational exponents on top. Okay. And your answer is just 1 over 5. Because 5 to the 1st is 5. Okay, then one more. We have a parentheses. Inside we have 8x to the 9th, y to the 3rd. And then underneath we have 27x to the 2nd, y to the 12th, and then a 2/3 power outside. So the top bases, we have 8 times x times y. On bottom we have a 27 times x times y. So 1 times 2/3 is 2/3 with the 8. 9 times 2/3 is going to be 6 whole. 3 times 2/3 is going to be 2. Now on the bottom we got a 1. 1 times 2/3 is 2/3. 2 times 2/3 is going to be 1 and 1/3. Okay. And then y, okay, 12 times 2/3 is going to be 8. Okay, now you got an 8 on top, but not on bottom. You do have an x on top and bottom, so you take out the one with the smaller power and minus 1 and 1/3 to the top, and that's 4 and 2/3. Okay. Now you get rid of your y to the 2nd and subtract 2, and that's 6. Okay. Now none of the exponents I ended up with, the 2/3, the 4 and 2/3, the 2/3, and the 6, none of them are negative, so we don't need to worry about that. Now we do have obviously some fraction exponents. Now we put the whole exponent first, y to the 6, it's on bottom. And we have another whole exponent with the 4. Remember, at 4 and 2/3, okay, The 4 is a whole exponent, so we put x to the 4th. Then we put our irrationals. We put times 8 to the 2/3 power. Circle the bottom. Then on bottom, you got 27 to the 2/3 power. Circle the bottom. And don't forget, you had x to the 4th, but you also have x to the 2/3. So you also need to bring over your x to the 2/3. Don't forget that. So with all these rational exponents, we're going to look at the cubed root list. Now, is 8 there? Yeah, it is. It's 2. So cross out the 8 and the 3 and put 2. Now, you still have 2 to the 2nd, but that's okay. Now, x isn't going to be there. 27, the cubed root of 27 is 3. So this goes away, and we now have 3 to the 2nd. Okay. Now, do you need this line? It depends on if your whole bottom exponents are whole or fractional. Well, they're whole, so we don't need this. Okay. Now, right here, I still have a rational exponent on top with that x to the 2/3. Okay, so you drop down your whole, the x to the 4th, times the 2 to the 2nd, and then your y to the 6th is on bottom. And then this one with the fraction, we make a cubed root out of that. And then in it, we put x to the 2nd. Okay. Now simplify. Oh, sorry, you also had the 3 to the 2nd. I forgot about that. That's a whole though. Okay, simplify your bases first. Outside number bases. 2 to the 2nd is 4. 3 to the 2nd is 9. Then your variables, you got x to the 4th and y to the 6th. And then your radical, all you have is the variable with its power, which can't be simplified. Okay? And that's the end of the problem.